So, um, I am planning on my big goal for this channel is to make a redstone computer that can do some things, which I'll go over my kind of plans and what I want from that a little bit later. Maybe I'll make it into a short. Anyways, so my big plan is to make a big computer in Minecraft and to kind of explain and teach what each of the components do and how real-world computers work via this game that I love so much. So, I think that we should go over some very basic binary principles, just some basics on how binary functions, so that I can start to introduce more and more concepts, and then eventually we can start really working on the project. So first of all, we have here a redstone lamp with a lever, and you can flick it on and off, and what this is representing what binary means. So we have a base 10 counting system, which is, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Those are all the characters that we have. And when you reach 10, it's just 1, 0, right? It's not a new number. Well, it is a new number, but it's not new characters. Binary is the same thing, but it is base 0. No, no, sorry. It is base 2. It is just using 0 and 1. And that's what this redstone lamp is representing. It's representing the 0 off, 1 on. This can also be used to represent something like true and false, This is false, this is true. And so, we can utilize this to do a whole bunch of stuff. But how can we really use this? Well, that involves this, which is logic gates. Now, logic gates take in some number of inputs, and then it gives an output based on those inputs, and based on the gate. So this, for example, is an AND gate, which only turns on the redstone lamp when this lever and this lever are on. So you see, when it's just one of them, then the lamp is off. When it's this one, it's off. When they're both off, it's off. But when I turn both levers on, then the redstone lamp turns on. Now, again, might not seem useful yet for doing computer stuff, but it is. And we will see why later. Here's another gate. We got the NOT gate here. The just reverses whatever input is given. So we have, it's off right now, but the lamp is on. Then we flick it on, and the lamp turns off. Again, might not seem useful, but it is. We have a more complicated one here called the XOR gate, which I'm going to get a good look at here. The XOR gate, XOR gate, or exclusive OR gate. That's what this is called. Basically, exclusively one or the other. You can see that when I flick this one on, it turns on. Great. If I flick both of them on, it turns off. When I flick just this one on, it turns on. When they're both off, it's off. So it is exclusively OR. It is only when it is one or the other that it will turn on. Now this is slightly different from what's called a just OR gate, okay? Now I forgot to make one of these, but that's partially because they're so simple. An OR gate looks a little something like this. It just turns on when one or the other or both. The difference between this and between the OR gate and the XOR gate is that the XOR gate does not return true, doesn't turn on the lamp when we have the AND, like that. Now, you again do not see the value in these probably, but they are very, very useful in doing larger concepts. Some of those concepts involve storage, and storage is something that we're going to go over a lot recently, a lot when we start this, so I'm going to do a brief explanation. In order to really do anything in binary, we need to store data. And you can kind of see here that a redstone lamp being on is not A redstone lamp being on is not stored data. Because if we try to move that data, god damn it, if we try to move that data like this, then it'll stop working because that lamp doesn't hold the on state. That lamp is only on because this lever is on. So, what we need is some way of transporting that on state, which we can do. I'm going to display this, kind of how it works, with a cauldron. You can see we push the cauldron, and this comparator, you don't really need to know what comparators do, but basically they can tell if a cauldron is full or not full. And so it's noticing that it's full, and so it's returning on, not full, turning false, or off. And so we can do that. We can move larger sets of this data, like here. If we want it to be on, then we flick it, and oops. If we want it to be off, then we can flick it, and that will turn it off here. But basically, we can have either an on or an off state. And if we like how it is, let's say we like it right there, we can push it like that, and then we can have these things take it away, and they are now in storage. Ignore that. Now they are in storage, and we can't access them, but we can move them to somewhere else where we can access the data. That's just a general understanding of what storage is and how we might see it later. But that's a really crappy design, because that's really big and bulky and just kind of bad. So I want to show you, right before we move on, this one last idea for how we can do it, which is how we're going to end up doing it a lot, and actually what we use over there, which is called locking repeaters. So when we have these things, repeaters, if we if we run a redstone charge from one repeater into another, then it will lock that repeater. You can see it's sealed off, meaning that any redstone input doesn't matter, is unaffected by it. And if we unlock it, then it cares. So we could actually flick this, lock it, and boom, it remains turned on. As long as this is on, this remains saved. And I meant to say locked, but saving is a great word for it because that's what we're going to use it for. It is how we save things. We save them by just locking them as how they are. So you see I just unsaved it, so it forgot, but then I can lock it again, and it saves the information. So this is what we're going to use mainly, and you can actually see a much larger example of how we can use this right over here, where we have a bunch of bits of information up here going in this tower, and then you can see we have this redstone line which locks all the repeaters which lead into these lamps, meaning that now my input doesn't affect it. If this confuses you, I have a better explanation on my channel already, but yeah. That is a general explanation of both general binary logic and some storage principles. Just a few bits of words that you're going to need to know. Sorry, vocabulary, perfect. Some vocabulary you're going to need to know. One, on or off. So this is a bit. Okay, 8 bits is a byte, and 4 bits is, I believe it's a nibble or a crumb. I'm not going to use 4 bits. Okay, that's one that nobody really uses. But yeah, so 8 bits is a byte, which you probably hear in stuff like megabyte, kilobyte, things like that. Yeah. So bits, gates, and storage. And yeah, so that is binary in Minecraft. Wonderful.